mathematicians came a lot later than other numbers. And to begin with, you had like one or many, and then you had like all the numbers except from 0, so like 7, 8. They used number systems with the base number of 10 or 20, and they ignored 0. Except for the Babylonian numerical system, they used symbols. And they had a wedge symbol, which is kind of like a Y, and this was used to represent the number 160 or 3,600. But the problem with this is when they had two of these next to each other, it could mean 61, 3,601, 3,660. So in 300 BC, they used two slanted wedges in between, so like that, to represent basically what we know as 0 now, but they just used it as a placeholder, so it didn't actually have a value. But then when the Greeks converted it back to their numerals, they just ignored the 0 or the placeholder altogether. So this leads me on to onto Zeno's paradox. So this paradox is the Achilles and the tortoise. So if this is 1 foot, and if Achilles ran 1 foot a second, but the tortoise moved a half a foot a second, Achilles would catch up to it in the first second, but the tortoise would have moved half a foot. Then in the next half second, Achilles would have caught up, run half a foot, but then the tortoise would have again moved a quarter of a foot. And you keep doing this, and it makes a sequence. But the problem with this is that Achilles never actually catches up with the tortoise, which is kind of weird thinking about it, because in real life, you know, if someone's running, you can run past them, even if you're running at the speed. So the tortoise is always ahead. But no one could prove that this was wrong, like mathematically prove that Zeno was wrong. He had taken this continuous motion and divided it into infinite steps. It would go on for infinity. It would go on forever. However, now we know that modern mathematicians, we deal with 0 and infinity, and this is what the Achilles heel was. They didn't use 0, they just didn't know. They knew about it, but they chose not to use it. So with 0 would be the limit, so the distance, they would get closer, so as the distance decreases, so he runs 1 foot, then a half a foot, it's getting towards 0. 0 would be the limit. However, Greeks didn't know this. So that means that it would take 2 seconds for Achilles to catch up with the tortoise, because he moves 1 foot, and then he moves another foot because it has a limit of 0. So if you subtract 1 to get 1, and then you subtract a half, and then a quarter, and so on until it gets to 0. Zeno couldn't prove this, but it didn't matter because it suited his philosophy. The first person to do this trick with 0 was a British person called Richard Swift. He found that the sequence got closer and closer to 0. There was another man at the same time, Nicholas. He added them together and got a harmonic sequence. However, the distances just got bigger and bigger, infinitely bigger, unlike Zeno's paradox, which they got smaller, as you've seen. So this is another one of Zeno's paradoxes, but it's very similar to the Achilles and the tortoise. It's just the alternate version. So to get from like A to B, you have to travel halfway. But to travel halfway, you have to travel a quarter of the way, and so on and so on. But there's no first distance, because if you say the first distance is 1/16, well, to get there you would have to travel 1/32. But then that's not, 1/16 isn't the first distance. So this is just the same, but in the opposite direction, and you have to know that 0 is the limit, otherwise it would just go infinitely back. So if it didn't start, what the Greeks thought, if you couldn't find the first distance and it kept going back, then the person couldn't actually start, so then how could they finish? So then it came to this conclusion that motion was an illusion. And this problem with zero comes up a lot also in like areas under a curve as well.